In this video, we're going to talk about how to use logarithms to solve exponential equations. So an exponential equation is something like this. If I have a to the x equals b. Now, I already know how I can get rid of a power, right? If I wanted to solve for x, if I had like x squared equals n, I would just square root both sides, and I'd say, okay, x equals the square root of n, right? Because the square root gets rid of the 2. And I have to do whatever I do to one side, I must do to the other. Similarly, if I have x to the 100 equals n, then I can take the 100th root of both sides, and I would get x equals the 100th root of n. Okay, but logarithms do something different, where let's say here, right, in this equation, my x is the power. So I don't want to take the xth root of both sides. That doesn't do anything for me. What would be really nice is if I could get rid of this a, okay? And there is something that does that, and it's called a logarithm. So what I can do is I can take the log base a of both sides, and if I do that, and this is how you write it, log base a of, when you have log base a of an exponent with a base of a, it undoes it. They cancel out. And so I end up on this side with just x, and then on the other side, I have log base a of b. Okay? So there's this correspondence now where if you see something in this form, you can remember that I can go back and forth. Another way of writing it is x equals log base a of b. And for now, we're going to stick with logs of mostly of base 10 and 2 and 3 and things that are a little bit easier to do. You'll see kind of what I mean here. So let's say I have, for example, number 1, if I have 10 to the x equals 457, and I want to solve this equation for x, I'm going to take the log base 10 of both sides. And when you're doing base 10, this is a notation thing. You don't actually have to write 10. It's the one of only 2 special logs that you don't have to write the number down. So if you leave it blank, there's no number here, and you just write log of 10x, it is assumed to mean that you are doing log base 10. And whatever I do to one side, I have to do to the other. So I'm going to do the log base 10 of 457. But wait a minute. How do I do this? Because if I look over here, well, x equals log base a of b. Okay, so log base 10 of 257, but I don't know what that is. Luckily, your calculator, if you look at your graphing calculator or scientific calculator, should have a button that says log. So if you type in log 457, you'll find that x is equal to 2.66, approximately. Should be what you get, okay? But let's do one that you actually should be able to do without a calculator. Let's look at if I said you had log base 3 of x is equal to -4. And I wanted to solve this. Well, if I look over here, right, I know that, okay, if I go back and forth here, I'm going to have that I can rewrite this equation in terms of an exponent instead of a logarithm, where I can write this as 3 to the -4 is equal to x. Okay. Now, the 2 ways you can do this is if you can either look at and just say, okay, well, it's always going to be the base raised to this other power, it equals the thing over here. And you can kind of just memorize that and run with it. If you want to understand why that is and what we're actually doing, remember the derivation we did at the beginning where we went from one to the other, and we can go in the opposite direction, where what you can do is you say, well, if this statement is true, if log base 3 of x is equal to -4, then it must also be true that 3 raised to the log base 3 of x is equal to 3 to the -4. And then what happens is, just like log base 3 of 3 cancels out, the same is true for 3 raised to the log base 3 of anything else. So the log base 3 and the 3 cancel, and I'm left with x equals 3 to the -4. So this is kind of how it comes about that you get this, or you can think about it in terms of how we did at the very beginning of the video. Either way, you should get x equals 3 to the -4, and then you should be able to remember that, oh, 3 to the -4 is just 1 over 3 to the 4, which is 1 over 81. Okay? We'll do a couple more. Let's say I have log base 2 of 8 equals x. and I want to solve this for x. Well, I can rewrite this in exponential form. 2 to the x equals 8. And then I ask myself, 2 to what power is equal to 8? And I'd think back and say, well, 2 times 2 is 4. 2 times 2 is 8. Great. So 2 to the third is 8. So x equals 3. Cool. And one more example. Let's say I have log base x of 4 equals 2/3. What do I do here? Well, I say x to the 2/3 equals 4. And once I'm here, then I say, how do I solve this? And now, I know it's been weird because we've been in let's get rid of the log in this video so far. But here, we actually do want to get rid of the power instead of the log. So what I'm going to do is I'm going to raise both sides to the 3/2 power. Because if I do that, right, the way you do a power to a power is you multiply the powers. So 2/3 times 3/2 is 1, and I get x equals 4 to the 3/2. And then I can do this out. Okay, this 1/2, right, is just the square root. So the square root of 4 is 2. 2 to the 3 is 8. So the 4 to the 3/2 is going to be 8. So this is how you use logarithms to solve exponential equations, and also use exponents to solve equations that use logarithms.